Okay, so the purpose of this video is to look at the ways to find the zeros of a polynomial by looking at its graph. And if you look at this first function here, the first function says we have y is equal to x squared plus x plus 6. I'm sorry, plus x minus 6. And we notice that this last term here, the linear term, has a negative sign in front of it. And that lets me know that when I factor, my signs have to be different. So one has to be positive and one has to be negative. And now I'm just looking for those numbers that multiply together to give me 6, right? Because I have a 6 here on the end here. That's the constant value. And what numbers will multiply together to give me 6? Well, I know that 1 times 6 will give me 6. And I know that 2 times 3 will give me 6. And we're just focusing on integers today. Once I figure out the numbers that multiply together to give me 6, I then need to figure out which pair will give me a 1, because I have a 1 in front of the linear term, right? A 1 in front of the x. Well, I can't get a 1 by combining 6 and 1, so that's not going to work. But if I do take 2 and 3, that will work. So the signs are going to be different. I know that because this is a negative sign. And I know that the biggest number takes the positive value because there's a plus on the linear term. That means I'm going to use plus 3 and minus 2. And of course, in the first positions, I'll just use x and x. Now let's check this. Let's FOIL this and see if we did this correctly. I know that x times x is x squared, which is good. And then on the outside, I have negative 2 times x, which is negative 2x. And if I add 3x, positive 3x to negative 2x, that gives me 1x. And then positive 3 times negative 2 gives me negative 6. Well, if x plus 3 is a factor, then the 0 would have to be negative 3, because negative 3 plus 3 is 0. And if x minus 2 is a factor, then positive 2 would have to be a 0. So let's take a look at the graph and double check our work here. We figured out that x plus 2 is, x plus 3 is a factor, which means negative 3 is a 0. And we figured out that x minus 2 is a factor, which means positive 2 has to be 0, because 2 minus 2 would give me a 0 for that factor. And as you can see by looking at the graph, the y values are both 0. So the zeros are x is equal to negative 3 and x is equal to positive 2. Okay. Let's take another look here. We'll look at a different graph. This time we're looking at, let me zoom in here. Sometimes it's hard to see unless you zoom in tightly. This is going to give us a better idea of what's going on here. We're going to take x squared minus 9x plus 20. And we want to know, what are the zeros? When is this function equal to 0? That's the question here. Well, we could look at the graph because we have the graph, but if we did not have the graph, we would have to factor. So I'm going to set up my parentheses to factor this. And luckily, the first term is positive 1. So I'm going to have an x here and an x here. And now I'm going to focus on this 20. What numbers multiply together to give me positive 20? Which integers multiply together to give me positive 20? Well, that's going to be 1 times 20, 2 times 10, and 4 times 5. Those are the only integers that will multiply together to give me a 20. And now I'm going to focus on this term in the middle, which is negative 9. Well, let's think about this. can I get a 9 or a negative 9 using 1 and 20? That's not going to happen. I could get a 21 or a 19, right? If I added or subtracted, but that's about it. What about 2 and 10? Can't do much with 2 and 10 either, as far as a 9 is concerned. But 4 and 5 does combine to give me a 9. This plus here means the signs are the same, and this minus means they are both going to be negative, so that's going to be x minus 4 times x minus 5. And if we check this, x squared, x times x is x squared. I have negative 5x on the outside, minus 4x, which is negative 9x. That's good because that's what we have for the linear term. And then negative 4 times negative 5 is positive 20. So this did factor correctly. And now that I have factored it, I should be able to find the zeros. What value of x would make x minus 4 0? Well, that would be positive 4, which is our 0 right here. If you look at this term here, if you look at that factor, if x minus 5 is 0, then what value of x would make that factor 0? Well, it would have to be positive 5, right? Because 5 minus 5 is 0, and there is that 0. And we'll highlight these using Desmos. And as you can see, 5, 0, and 4, 0 are my points on the x-axis. Notice that the y values are 0. That's why they're called zeros. So our zeros are x is equal to 4 and x is equal to 5. Okay. Notice on this last problem here, I'm going to just look at the zeros. I know that one of the zeros is negative 6, the other 0 is negative 2. And what does that tell me? Well, it means that one of the factors has to be x plus 6, right? Because if x plus 6 is a factor, then negative 6 would be a 0. And we know that negative 6 is a 0, right? And if x is equal to negative 1 is a 0, then x plus 1 would have to be a factor. And if we FOIL this, x times x is x squared, then we have 1x plus 6x. That gives me 7x, and then I have 6 times 1 is 6. Notice that this is the factored form for this polynomial here. So sometimes just knowing the zeros is enough to get us very close to what the original equation looked like. So that's another reason for knowing how to work with zeros. And finally, let's look at one more problem here. I'm going to have to zoom way out to see these zeros. But it looks to me like I have a 0 here at negative 8 and a 0 here at positive 10. And if I wanted to know what the equation might look like, just using those zeros, well, if negative 8 is a 0, then x plus 8 has to be a factor. And if positive 10 is a 0, then x minus 10 has to be a factor. So this is the factored form for this polynomial here. And notice that x times x is x squared, which is good. Negative 10x plus 8x is negative 2x, which is good. And then positive 8 times negative 10 is negative 80. So hopefully you now know that when you factor and set the function equal to 0, you can identify the zeros, but also if you know the zeros, you might be able to figure out what the original equation looked like as well.